Alright, welcome back to Earth and Space Science. I hope you guys had a nice long weekend and enjoyed your Easter break. We've been talking about clouds and cloud forms and cloud naming conventions. Today we're going to be doing 6.5 about precipitation, which is the stuff that falls out of clouds. Things like rain and snow and hail and sleet. All are different forms of precipitation. So let's get started. Precipitation is any product of condensation of water vapor that falls due to gravity. Condensation is how liquid droplets appear in clouds, which are made out of water vapor. And depending on the temperature range, you can end up with liquid water falling from the sky, such as rain, solid forms, snow, sleet, hail. All these different things count as precipitation. This diagram shows our different forms. It also throws in things like dew and mist. Dew is a form of condensation. That doesn't necessarily fall due to gravity. Dew forms on solid surfaces, so it's not in a falling situation. Mist doesn't also form. It stays suspended in the air with like tiny little droplets that you walk into. But we know what mist and fog are like. But they're all types of condensation, so it kind of works. Okay. So these different types. Formation first. It's caused by two different reasons that can happen. First is as the air is cooling. The cooler the air is, the less water vapor it can hold. It reaches that saturation point, and then the liquid water comes out of the air. As the air cools off, you're lowering it, and so whatever water vapor that is there already suddenly hits the saturation point, and we get cloud formation and precipitation. This happens pretty frequently with storm systems. There's often an updraft of warmer, moister air, so just showing this diagram here. It hits the colder part of the atmosphere, and then there's rainfall behind it. You can also have precipitation due to increasing the amount of water vapor in the air, usually due to evaporation. So, different types of precipitation. Rain. Rain is liquid water droplets. There's lots of different sizes that you can have. We've all seen those days that have like little bitty spritzy raindrops or the great big fat ones. It just happens depending on what the environment is like. The size is based on the updrafts, how much vertical wind is pushing upwards, holding the raindrops in the air longer. The longer things are in the air, the bigger the raindrops are going to be. There also can be evaporation. If the raindrops are falling through dry air, then they can evaporate away before they even hit the ground sometimes. Most of the fresh water here on Earth is produced through rain. The rest of it is from snow melt. And so rainfall is super important in terms of what kind of plants can grow in a location, agricultural yield, what kind of biomes develop. I mean, the amount of rainfall is super important for life here on Earth. Raindrops are not actually shaped like tears. They kind of look like that in our photos, like down here, but that's just because of a little bit of drag. They blur a little bit because of their motion. They're actually mostly spheres, or sometimes shaped like umbrellas because that upward shape of air holding them up a little bit. Okay, snow. Snow is made out of ice instead of liquid water. It's a crystalline form of ice with an open, six-sided structure. They have six-pointed symmetry, so they grow in 6 different directions, and they're symmetrical all the way around those 6 ways. And there can be, difference from very big, fluffy snowflakes to smaller, harder snowflakes. But they have to be very, very cold, much colder than just freezing. It has to be super cold, which is what we call super cooled, when the droplets freeze. Otherwise, it just freeze straight into ice, and you get ice pellets instead of snow. So up to around negative 35 degrees Fahrenheit is when snow forms. The overall shape of the snowflakes depends on things like temperature and humidity. There's sort of this urban legend that every snowflake is unique. That's not necessarily true, but there's definitely enough variation that they're mostly unique. It'd be like having an identical twin person somewhere on Earth. Okay, sleet. Sleet is also ice, but instead of having that open, loose, lacy pattern that snow does, you get tiny little ice pellets instead. This happens because the snow melts back into a liquid water as it passes through warmer air, and then it freezes again if it hits another band of colder air. And so we have snow that melts into rain and then freezes into ice. And this diagram shows kind of how that happens. Most precipitation actually starts off as snow, just because it's so cold in the upper atmosphere. And then it depends on what it passes through to determine what it lands like here on Earth. So if you have snow high in the atmosphere and it passes through a warm air, it just lands as rain. If there's like colder air or the ground is cold, you can end up with freezing rain. If there's enough colder air, the rain will freeze into solid ice pellets. It melts briefly and then freezes again, then you get sleet. And then if it's cold all the way down, then you can end up with snow reaching the ground. Hail. Okay, hail is pretty unique. Hail is a solid ball of ice somewhere between 0.2 and up to 7.9 inches across. The largest hailstones ever found have been up to 1.1 pounds, which is enormous. These are huge chunks of ice that can cause a lot of damage when they fall from the sky. They can cause severe damage to crops, homes, vehicles. Most everybody's seen cars that have been dented up from hailstorms. They can break glass. And what happens is that a hailstorm is literally sort of being juggled in a storm system. It's falling downwards as ice pellets, and then updraft catches it, pushes it back up into the upper atmosphere where it's cold again, and whatever water had built up around the ice pellet freezes in a new layer of ice, and then it falls and then gets picked up again and falls and picked up and falls and picked up. It's being juggled up and down through these warm and cold layers, and every time it hits the colder layers, there's another layer of ice being added. And this can happen for up to half an hour that it's being juggled in the air until finally it's so heavy that the updrafts can't lift it anymore and it just falls. The other way that hailstorms grow is through sort of conglomeration, where you have smaller chunks of ice that hit each other and then stick together. And so sometimes you get sometimes hailstones look like gobstoppers. They're in layers, but it's mostly smooth all the way around. But other times they're like knobbly things because they're made of smaller pieces that are stuck together. In order for hailstorms to form, you have to have really strong updrafts, which means that these are associated with very severe storms. And also, there's kind of a thing that happens to the color of the light that comes through severe storms, that kind of can produce hailstorms. There's sort of a green tint that the sky can get during really bad storms. And that would be an indicator for a possible hailstorm as well. So here's what I was talking about in terms of hailstorm formation. They're basically just like a cycle here, where there's the stones start to form high up, they fall down through the freezing level, raindrops get sucked in, and they get this wet layer around the hailstorms, they get lifted up again and freeze again. And it just goes round and round and round until finally they're too big to fall, and they fall. Here's what it looks like if you cut a hailstone in half. You can see the actual layers on it. And here's an example of some of the damage a really severe hailstorm can do. Hailstorm, that case. Like they're just punched through, almost like someone put a baseball pitcher, like just shooting these things right at the building here. They must have had a strong horizontal breeze too to throw them this way. But you see broken windows, broken siding. I mean, it destroyed this house. Okay, that's it for today's notes. So there's a worksheet to do online, multiple choice questions. Please use the notes while you do the worksheet, and you can do it as many times as you like. The worksheets from now on, you're going to be able to resubmit as much as you want to get the grade that you want. I hope this helps. Have a great day.